All right, thank you all for joining us. We'll be starting here in a few minutes. Just waiting.
Just want to reconfirm, Darren, you can see my proper screen with the headline slide?
Yep, coming through.
All right.
Just waiting for a few more people to join and we'll get started. See the numbers keep climbing. We'll be starting here in just a couple more minutes. All right, we'll give it one more minute and then we'll get started. All right, we're going to go ahead and get started. Welcome, everyone. This is the Enhanced Retrocommissioning presentation from the SRP Business Solutions team with ETC Group as the main presenter. Just some housekeeping real quick. Please feel free to use the chat feature as we go through the presentation. But please note that if there's any longer questions, we're going to go ahead and answer them verbally at the end. My name is Darren Gest. I'm one of the engineering managers here at Resource Innovations. I've been working on the SRP programs now for over 11 years, and I manage the retrocommissioning program specifically. I do want to mention that we will be giving away a couple Nest thermostats with this presentation, so please stay on till the end. We'll announce the winners at that point. With that, I'll start the presentation. I'll discuss the specifics of SRP's retrocommissioning program a little bit later, but first I'd like to introduce ETC Group to go why you should consider retrocommissioning and monitoring base commissioning for your facility.
Great, thanks, Darren. My name is Chris Jackson. I've been in the energy efficiency field for 14 years now. I moved to Arizona in early 2014, but I've been working with SRP's program since about 2009, which is coincidentally the same year that April started with ETC, and she became our monitoring-based commissioning director in 2018. So you can see we've been around a little bit. We're in the industry. We were laughing the other day at just how much the industry has changed since we started. Today, we're presenting on monitoring-based commissioning, and that didn't really even exist when we started. We were still doing the old school retro commissioning up on the roof, manually testing the dampers and valves. As for ETC, we're a group of energy efficiency engineers, been in business for over 33 years now. We're headquartered in Salt Lake, but we've got a fairly large office here in Arizona. And our services include energy audits, retro commissioning, and monitoring-based commissioning, which are the topics of this presentation, as well as new construction commissioning and turnkey project delivery. Before we dive in, we're going to have a safety minute. SRP likes to include a safety minute in the beginning of their presentations, so we obliged. For ours, I want to keep to the theme by sharing this exploded VFD. Definitely not safe. No, this guy didn't get blown up. He's just kind of inspecting the wreckage here. The message is that you can avoid this with analytics. You can use data for preventative maintenance. Most drives have an internal temperature sensor that you can read. And if that temperature starts rising, you're able to go check the fan or the filter before it becomes an issue. So now that we have all this data available, there's some really cool things we can do to watch filter loading, chiller surge monitoring, and even vibration sensors. Moving into the start of the presentation, a bit of an outline slide here. I'll be starting with retro commissioning, and then I'm going to hand it off to April to go into monitoring-based commissioning, and then Darren is going to close with the SRP program. A little bubble here. It's energy audit's more fun than a tax audit. So retro commissioning 101, I'll do a quick version here. I probably have about 10 minutes on my slides. This is where we get started. As I mentioned, the idea of retro commissioning has been around for a while. You might hear terms like building tune-up or low-hanging fruit. And I'll go into some of the topics a little bit later on the terminology. But in general, you're going to be looking for a savings of 10 to 25% and a payback from 2 to 4 years. It sticks to reprogramming measures, not so much in the capital measures. We can sometimes attach a lighting measure or occupancy sensors, but anything bigger than that isn't really considered retro commissioning. The first slide here is the why. They always say you want to get to the why. Why do you want to do this? The answer is results. So here's a pretty large healthcare facility in Salt Lake City. They were able to drop their energy spend from 4.3 million down to 3.5 million a year. So that's a pretty big amount of savings, $730,000 a year, and that is just from reprogramming measures. This one didn't have any capital equipment. The other why, this graph shows a multi-year project, is the cash flow. So with the red bars representing the cost and the green bars representing the savings, after the retro commissioning is done, the red bars go away and you're left with the green bars. And then where we're going to get to April's slides and the monitoring-based commissioning comes in at the end, or at the beginning either, it will enhance the green bars during the retro commissioning and then maintain the green bars after the project is done and you continue on. This particular facility ends up with 1.6 million a year in net cash flow at the last year of the job. And here is the terminology slide. So there are a lot of common terms out there, and they can be defined slightly differently by different organizations or utilities or any other group. So it's important to kind of know what you're asking for. So I'll run through these quickly. Commissioning, I'll use the analogy that you're buying a new car. And before your car leaves the factory, comes off the assembly line, they're going to make sure that it's thoroughly tested. And so that's how you think about commissioning. Then you can think about retro-commissioning and existing building commissioning. They're pretty similar terms. This is more now you're buying a used car. Before the dealer sells it to you, they're going to do a 500-point inspection to ensure that all the components and systems are working as new. So that's when you hear those. Retro-commissioning is a little bit different. So now you've had your car for many years, but you kind of notice that your mileage is getting a little bit worse. You take your car into the mechanic and identify the source of the inefficiency. So rather than testing every component on your car, they're going to focus on the systems that aren't working correctly and really dial in their efforts there. There is a couple of things in retro commissioning where it gets a little bit interesting. So what if you can do better than the original design? So you can find measures to optimize things better. That's definitely a piece of retro commissioning. And then the other one, what if you don't even know the original design? So you go into a really old building and you're just going to do your best to make it run as efficiently as possible. After retro commissioning, you might hear the term turnkey. So that's actually doing the work. So keeping with the mechanic, this is when your mechanic calls you up and says, hey, I found an issue with your fuel pump. Do you want me to fix it? Of course, if you said yes, that would be a turnkey retro commissioning. You could also have the option to say, no, I'll take it home and fix it in my garage myself. Fault detection and diagnostics, FDD. It's kind of a broad term for analytics. It really could be anything from, a pretty simple analytic, if-then statement, is your damper working, to a more complex nested statement. And the analytics really encompasses everything from dashboards to views to KPIs. You might hear the term continuous commissioning. That was an early term in the industry. I believe it was patented, so people stopped saying it. We kind of moved on to the term of monitoring-based commissioning, MBCx, which is what we'll talk to now. That really combines a bunch of terms here that we're going to use analytics and remote engineering and reporting to deliver the savings and maintain the savings. And keeping with the vehicle, now you're going to see, I thought this was really cool, modern vehicles can diagnose themselves. So this one says, an unexpected condition has been detected. A replacement part has been pre-shipped to your service center. Please reach out and schedule an appointment now. That is how I like to think about monitoring-based commissioning. So now that we have that terminology, what do you want? So I have kind of what you probably want. Not everybody wants the same thing, but most building owners are pretty well aligned. Maximize added value, minimize unnecessary labor spend. You definitely want a data-driven approach whenever possible. This is when we're going to get again to MBCx. We like to say ASHRAE level 1.5 to 2.5. They kind of go 1, 2, 3. But level 1 by itself isn't usually enough. And level 3, in our opinion, seems a little bit overkill with deep energy models and sometimes contractor bids that aren't necessary to move forward. You want something actionable, something that you could take out to a bid or do internally. You don't want to find things that you have to research more. Lastly, you want savings. You want to deliver the savings and maintain the savings. You want your bill to stay down and keep dropping. Quick slide here. I mentioned ASHRAE. So ASHRAE is probably the most common energy audit definition. They do have the level 1, 2, 3. The slide isn't totally complete. You've got some bullet points here of what the levels mean, but the book will have all the details. So if you're interested in learning more about an audit, that's the book to start with. But the first step is almost always benchmarking. This is a part you can do yourself without consulting the experts. You can compare your facility, your energy use against other facilities of similar types. And you can compare your energy bills against your previous energy bills to see if you are getting better or getting worse. There's a bunch of tools out there to help with this. ASHRAE has the CBEX, which stands for Commercial Building Energy Consumption Survey. There's the Energy Star Portfolio Manager. And ASHE has one called Energy to Care for hospitals. And of course, we've all seen plenty of the homebrew Excel spreadsheet. Maybe I'm a little bit of a nerd here, but I keep a spreadsheet of the bills in my house. so I can see where I'm expecting them to be every month. Moving into the audit itself, the retrocommissioning study, this is where SRP can help you bring in the experts, and ETC group can certainly help your facility. We're going to come in and gather a ton of information. We're really going to dive in and look at the major energy using equipment for your facility, equipment lists, nameplate data, drawings, old studies, reports, graphics, sequences. We might perform some functional testing. We're probably going to trend systems, determine how they're really operating. We want to see how they change in response to occupancy and weather. We want to find areas where they aren't running how they were designed. And even if they are, we want to mention and find areas where they could be running better. You can see here, there's just a couple of examples where the data really starts to pile up. So that data-driven method. The old school method, we had a bunch of pages on clipboards and Excel pivot charts and tables. So this is where we're really happy to move forward into the new method that April will get into here. Common findings or opportunities. I'm not going to read all this slide. These are the things that we'll usually find when we do a retrocommissioning. We'll catch broken things that maybe are stuck dampers or valves that aren't functioning as they're intended. But if we have that analytics or monitoring base with the trending, we can find things that might be running okay, but could be running better. So we're able to really get eyes on the operation to optimize them. A lot of common things would be poor part load operation, setbacks and resets, overpumping and overcooling, which typically leads to reheat. I like this graphic here. It kind of shows an easy version of airside economizer operation. So if it's hot outside, you probably want minimum outside air. And if it's mild outside, you want maximum outside air. So just a simple illustration here of some things that we're looking for. And now, lastly, you've done your retrocommissioning. You've hopefully enhanced it with some use of analytics or MBCx. You've dropped your bills. How do you keep them down? You want to maintain the savings and prevent the drift. As seasons change, you'll want to fine-tune your resets. Make sure that your pressures and temperatures, set points are driving up and down as needed and when needed. You want to keep your eyes on the systems. That'll help you identify additional opportunities. And with monitoring-based commissioning, you almost think of it like you have an engineer on retainer, that you can have an issue in your building and call them up and somebody can look at your same data with you and help you out. So this is where April comes in, and I will hand off to her.
Thanks, Jackson. Okay, do you want to move on to the next slide there? Okay, so I want to spend just a second on this graphic that Jackson kind of threw up there with his really quick explanation and just get a little bit deeper. So, Jackson gave a really good overview of how recommissioning works. And I remember, 10 years ago, going through these projects, being so excited at the results, being so happy at the savings that were achieved and the goals that were reached in those projects. But every time we'd walk away, there's this little piece of you that would know that some of those hard-earned savings would degrade over time, or that energy use would drift up. So that's what drift is. And actually, drift happens whether you do a recommissioning project or not. It's just the nature of things. And recommissioning is such an amazing way to continue to capture, to improve, and do those things. And what we're going to talk about today is that now we have new technologies, this big data analytic technologies that have now become available. And right when they started to hit our industry, it became so clear that these technologies are what can change that drift story. So if you look at this green arrow, that first green arrow is the recommissioning project. So large drop in energy use. And then if you do nothing over time, and depending on the characteristics of your building and what's happening to operate that building, drift's going to happen at some amount. So that's that other blue arrow that's going back up. Now we've learned that if you actually apply these monitoring-based commissioning tools, so these data softwares, and I'll talk a little bit more about what those are, during your recommissioning project, you can achieve this orange arrow that drives energy savings and that energy reduction even more. And then if you continue to use these tools after your recommissioning project is over, you can achieve this purple line, which is adding to get even more savings over time as you continue to work on systems, continue to peel back those layers of the problems and find more savings. So really the entire green shaded area is the potential that monitoring-based commissioning can bring as far as the savings picture for a building. And also it's really cool too, we'll talk a little bit about how monitoring-based commissioning does more than just energy. It really is a way to start getting at buildings that operate more comfortably and more safely. Right, next slide, Jackson. Okay, so I want to give you just a quick sense of what some of these FDD or monitoring-based commissioning softwares, what they can look like. So they are a single platform for all of your data to live. So if you have energy data coming from a utility company, that can be connected into it. If you have multiple BASs in a building, just evolving over time with multiple systems. I think a lot of us live in those kinds of environments. All of those building automation system, all of that data can get connected to one platform, which is just really astounding by itself. You don't have to log into a bunch of places. It's pretty seamless. And all of that data, all of those individual data points come in and they get mapped. So they get identified by the system what they mean. So which pieces of equipment they're connected to. For instance, a temperature sensor, maybe a mixed air temperature sensor in your air handler gets brought in, it gets mapped and it gets tagged so that software now knows that is a mixed air temperature sensor and it knows what that means and how to pay attention to that data. Now, once all of that data is brought in, mapped and tagged, it gets put through rules. So rules are condition-based algorithms. So they're basically math equations. And they pull in and they say, okay, I know this piece of data is a chilled water valve and it should be closed, but I see a temperature drop across the chilled water coil, which means, oh no, I'm gonna fault that or flag that. And that can become a thing to find that's broken in the system. And that's happening on a continuous, like normally 15-minute interval basis. It can be really any interval that makes sense for your data. But that data comes in and gets continually put through these rules, and then faults are found and reported on an ongoing basis. These software platforms also have tools beyond faults. So things like dashboards or regressions so that you can make a baseline of current performance compared to previous performance and understand the differences between those. So lots of different bells and whistles that can come come with these softwares and really to be useful in analyzing more complicated systems that maybe can't just rely on some simple faults to show what's needed to get to a more optimized state. And then also reports are really important. So these softwares should be able to, in some way, tell you what to do in a very clear, prioritized way and very actionable, because we don't want these softwares to become something that just is in the dusty corner and doesn't turn into actual real life value. So just to give you an idea of how much data can be coming in, the biggest facility we have connected has over 1,600 terminal units. And you can imagine there's no way that a human can go through a building automation system and the graphics and find, problems with those 1,600 different pieces of equipment on every 15 minutes. That's just not possible. So there's a lot of value in being able to apply these analytics or the software to numerous equipment. So on the right here, I've got a list of essential rules, and this is just, I'm not going to go through and read each one, but there's rules for air handlers, for central plants, and then I have these ones highlighted here for terminal units, because again, this is where you can deploy across just lots and lots of equipment. Okay, thanks, Jackson. So if any of you have been, I'm going to just give a couple of quick examples of how these faults work. If any of you have been through a retrocommissioning project, you're probably familiar with scheduling. It's one of the most common and really effective ways to reduce energy in facilities that have some predictable occupancy. And I found they're also the most likely to evaporate. These type of savings are most likely to evaporate over years period, because things change in the facility. just that it's so dynamic that schedules don't always continue to match, and maybe those can go away. This example is a screenshot of what the faults look like at an outpatient treatment center there in Arizona, which operated on an 8 to 5 schedule. And shortly after implementation, we started to see these little purple blocks pop up. So these purple blocks, again, are going to be the faults that are occurring. So we know what the schedule is, and those terminal units are no longer meeting their schedule setbacks. And so they start to throw these faults. We talked to the facility operator and found out that some of the rooms were just too hot. And so he was concerned that it was coming from these schedules and rolled some of them back and took away the one on Saturday, which was kind of the biggest savings. We looked with them into the data, so really using data-driven approaches and not just telling him he's wrong, because he wasn't wrong. Those rooms were hot, but we found out they were hot because their set points had increased after a strange power bump and a glitch where those set points just went back to 80 degrees. I don't know why anyone would ever want that, but that's what they went back to. And so a quick fix to the actual, that core issue, fixing that set point, allowed those schedules to be put back in place, and then all of these faults disappeared. Okay, the next example I gave a little preview to earlier is a leaking chilled water valve. So this is another really common thing to find during a retrocommissioning project or a monitoring-based commissioning project. So the first graph has 3 lines. The blue is the mixer temperature coming into the coil, in an air handler, and the green line is the set point for what they want out of the unit. The red is what they're actually getting. So you can see the red is really overcooled. It's much colder than they want. And if you look at the bottom graph, that's showing that blue line at 0%. So that valve is closed almost all of the time. And so what we're seeing below is those orange bars, those are our faults, showing that, oh no, this valve is closed and we're seeing this temperature drop. That isn't right. Here are some faults to show that. So we communicated this to the facility team. They were able to go replace the valve actuator. And you can see on the 15th that red line now jumps back up to the green line. The unit is now controlling to the appropriate temperature it was intending to control at a much lower energy. And that really at the end of the day, this is the kind of thing that occupants won't ever tell you that there's a leaking chilled water valve. Because reheat is there to just warm that air right back up. There's all that energy loss without anyone there to really complain or let you know what's happening. So it's more challenging to find this kind of thing. And this is where analytics can just be so powerful in finding ways to reduce energy with no impact to the space. They still experience a happy, comfortable space. Okay, so this is one more, this is another example of when we don't use faults, some of the other tools we can use. So this is an example of a chilled water plant dashboard. So chilled water plants can get a lot more complicated, and there are faults to use there, but not enough to really get to real optimization in your chilled water plant. So we use dashboards to help find and get to more comparative analysis and other techniques so that we can find ways to make those chillers and the plant sequence more efficiently. So this is an example where this dashboard led us to a comparison of 4 different chillers. So this is the graph in the front here that has red line, green, purple, and blue. And that red line is a much higher value. It's the evaporator approach on that chiller. And it's higher than the rest. And some other data led us to the root cause that this chiller was undercharged. It didn't have enough refrigerant. So we communicated this to the plant operator, and they let us know, well, I've got service scheduled for the end of the year. I'll wait then and we'll recharge it. And he reviewed the report and realized there were $5,000 of savings that he could grab if he were to do it quicker. So he was able to actually bring in his chiller service contractor, get the chiller charged, and you can see here where he did that. And now the red line is much more in line with the other machines. And improving the efficiency of that chiller got him those savings quicker. So really it was a data-driven decision that he made instead of waiting for something that was on a regular schedule to bring that forward, get it done when it needed to get done, and move the whole plant through a much more efficient season. Okay, so I just wanted to touch on, you know, at some point when we have all of this data flowing into these systems, we have to ask ourselves, what else should we be doing with it? And I think that the most obvious thing is to monitor comfort. This is really, if you ask any facility engineer about their pain points, they are always going to say, well, maybe not always, but most of the time they'll say that they cannot stand it when their phone rings for hot and cold calls. And those are fundamentally comfort issues. So in this report, you can see that 88% in the green circle there, that represents all of the terminal units, all of the spaces in the entire building, averaged together as the percent of time that's occupied where the zones are meeting their temperature set point. So they're meeting their set point, which we assume means the people there are happy. And so that's really great, but we can probably improve that. And so the table here on the bottom right shows the best opportunities to improve comfort. And all of those listed there have a 0% comfort key performance indicator. So they're never meeting their temperature set point. So there's something going on with these boxes. And so what we can do is go into the data, we can look at those terminal unit analytics and find out what's happening with each one. And you can imagine that if a facility team were to address a handful of these, you know, 2 or 3 per month, by the end of the year, you'd have a different building. Oh, goodness, hold on, I've got to plug in my laptop, sorry. I've got to notice my battery was about to die. You can imagine that at the end, that facility could operate be a completely different facility. And it could even reduce those reoccurring pesky calls that just keep happening and make them stop, which is really cool and exciting. All right, the next consideration is the critical spaces in the building. So some building will have more critical spaces than other. I'm showing here some operating room key performance indicators. So operating rooms obviously are very sensitive spaces, probably the most sensitive spaces in the built environment. And we care about how pressure, temperature, and humidity are being maintained in those spaces. So you can imagine that that's more important than all the energy use in a hospital, really. And so showing that your retrocommissioning project is going to either not impact at all or positively impact these type of critical spaces, and that you can pay attention to those things moving forward in perpetuity, really brings a lot of value to monitoring-based commissioning as just like a really awesome adder beyond energy. Okay, so I wanted just to touch on reporting because I think it's really important. This is what gets to making sure that people understand why this is happening, why we're doing monitoring-based commissioning, what the value is of it, and what actions need to be taken. So the reporting is a really an opportunity to set and really be transparent about any goals that your facility might have. So whether you have energy goals, Chris talked about CBEX, or how your maybe Energy Star, how your building's performing, you can put those into a report. You can compare to your baseline to see if you're still maintaining that really excellent performance after your retrocommissioning project, that you're still able to maintain that same performance. You can do actual utility bill analysis and see what dollar savings you're achieving. You can also show other metrics that are important that characterize the building's performance. We call those KPIs, so key performance indicators. So things like the total air handler fan power, or the central plant efficiency, things that if they were to have some radical change would be a great flag to let everyone know something's changed and we need to address it. Off to the right on the second page, these are the high priority items that are coming out of the monitoring-based commissioning, both the software and the services. So these are the things that the system is flagging, and we're saying, okay, these are your important things to tackle. And it's so important in these reports that these are really actionable and that they are helping the team really focus on where they're going to get the most value from their time. Okay. And then, maybe it seems so obvious, but you have to fix things. Things have to get done, or else it's just another software that really isn't bringing value. So I have to admit that the screen on the left, sometimes it can feel pretty overwhelming, especially at the beginning of using these softwares or beginning of connecting them to a building. There can be a lot of faults, a lot of problems. And so really taking the mindset of approaching it as, you know, eating the elephant, just one bite at a time. All the things don't need to be done right away, and using the tools to prioritize really helps to see the path towards getting to better operation over time. And of course, this is where a recommissioning project is so amazing. I do see some people try to use monitoring-based commissioning without a retro commissioning effort project. And that can be challenging to like get the resources together and the time from all the, you know, you might have strained facility personnel. That project is such a great opportunity to gather all these things and execute them and achieve a lot. And then you can just slowly do the, you know, the few boxes every week or whatever your schedule will allow after that. So getting things done is really, really important. And I've seen that this tool can really help facility teams move from very reactive to a more proactive place, right? Like they know these things are happening, they're aware of them, they don't have to get a phone call to let them know, they can already tell the faults that are happening. If your building has the robust and reliable building automation system, then this, you know, an enhanced retro commissioning using these monitoring-based commissioning tools is just such an effective way to get the best results possible. And you don't have to do everything manually anymore. So the left is like, you know, dear old spreadsheets. We love them, but not always the most effective way to go about trying to execute a retro commissioning project if you have these tools available. So, you know, the image on the right, that's what you can get out of the system. The old school way is a one-time snapshot, limited sample, and maybe your boxes you can only do, you can only look at 20% of your terminal units because it doesn't make sense to pay an engineer to go through 100% of your 1,000 boxes. And so that's where this new school approach of using these tools in your retro commissioning project, you can get 100% sample. You can look at all of your terminal units without the, you know, that huge amount of manual effort you would have to do otherwise. Okay, so persistence of your retro commissioning project savings and long-term savings really can be realized through these tools, and drift really can become a thing of the past. This is a real building in Arizona that had a really successful recommissioning project. You can see in 2015, and then so they used the tools during the recommissioning project, and then they continued to establish a really robust monitoring-based commissioning program. And every year since then, they have continued to reduce their total energy. This is electric and gas combined. And they continue to just keep marching through and reducing. So this is a vision for how great it can be, maybe best in class, but it certainly is attainable with these tools. And I think now I'll turn the time over to Darren to talk about the program.
All right. Thank you, Chris and April, for reviewing the kind of the details of why we should do retrocommissioning. And now I'll go through and review some of the specifics on the SRP retrocommissioning program so that we can hopefully see where your facility might fit in. Now, similar to kind of what Chris had alluded to, there's a lot of different potential measures within the retrocommissioning scope. Typically, the focus is on the HVAC side. So there's a lot of different controls programming that can be added in terms of reset strategies, as well as looking at, you know, broken chilled water valves, broken dampers. But it can also be more inclusive, and we can look at stuff like lighting controls, if there is a control system that we can take a look at and make some changes to. And it can even include process equipment. We've certainly done projects where customers have had industrial refrigeration systems, compressed air systems, and even other process equipment. If there's something where we can program it and the savings will be persistent, not just, hey, make sure you shut this off at the end of the day, then there's definitely a good opportunity to look at it for retrocommissioning. Now, in terms of who can qualify for SRP's retrocommissioning program, the typical program we're looking at is the 50,000 square feet 50,000 square feet of conditioned space or 1 million kilowatt hours in annual usage for the traditional program. And we're looking at facilities that are at least a couple years old with an EMS in place. So the EMS is probably the hardest thing that we see for some customers to meet. You know, if you don't have the ability to kind of control your equipment easily, we would highly encourage you to look at getting an EMS installed first before pursuing any sort of retrocommissioning, because it's very tough to keep stuff moving forward on a retrocommissioning project without that EMS in place. So we have other programs like our standard and custom programs that can help pay for some of the cost on that EMS. And so we would definitely encourage you to take a look at those first. In terms of the monitoring based, how we can qualify that, you know, we're looking at customers that are at least 150,000 square feet. And that can be, you know, if it's a campus, we can look at the total square footage of the entire campus, or a total of 3 million kilowatt hours in annual usage. So it's kind of an either or situation. It doesn't have to be both. Part of signing up for monitoring-based commissioning is that you agree to a 24-month monitoring period. So this will ensure that there's, you know, plenty of time to collect the data, review the data, and, you know, make sure that it stays implemented. You know, we certainly encourage you to continue the monitoring after that 24-month period, but that's the requirement for the program. And we even do allow buildings that are under that 2-year mark to qualify for this. You know, so far we haven't had a ton of facilities that have come through looking at it from a new construction standpoint, but the one project that we have done has been very successful. So even if you have a brand new facility and you're like, what more could I really need to do? I mean, some of the best projects that we see come through the program are on new facilities, just because you have all the tools in place to really get your building working very successfully. But it may have just been something where when it got originally commissioned, it just didn't get done very well. And so don't ever think that, hey, with a new facility, there's nothing that can be done. There are definitely opportunities, and we would encourage you to consider this, especially if you don't have any other big projects coming up. So the first step with any monitoring based is getting that software integrated with your existing EMS. And so that process can take some time. So we definitely would, you know, make sure that you understand up front that it may take 3 months, and in some cases it may take a year. It just depends on kind of the timeline and how easy it is to integrate with your existing system. And then we'll make sure that you know, the software meets all the requirements. One of the things that the QSP will do is go through and double check everything and make sure it's on point then. In terms of the rebates that we offer, the whole idea is that the retrocommissioning study itself should be at no cost to you. So we highly encourage you to come and apply for the program, assuming your project's a good fit. The QSP can come out and give you some recommendations without you having to pay for the QSP to be on site. In addition to the engineering support that's at no cost, we will pay an additional rebate to the customer themselves to do the implementation. So that's a 5 cents a kilowatt hour plus $100 per average peak kW. So the main thing is we require as a customer to commit to $3,000 up front, but after you meet that $3,000 implementation, anything past that is reimbursable. So depending on the overall cost, I mean, we've definitely seen some projects where the cost isn't that significant, and so with the rebate, it can end up paying for the entire cost of implementation. So it just depends on kind of what the scope is, how much work there might be, and so it can really be a very easy project, even if you're kind of limited on the capital. I know that a lot of facilities, it's tough to find money for different projects, but keep this in mind as a program offering that can really work with you if you don't have a lot of funds available. In terms of MBCx specifically, in addition to the rebates that we've already shown, we have an integration rebate where we will pay 50% up to $15,000 initially for integration, and then on the back end we'll pay the other 50% up to $15,000 if you go forward with doing the implementation. So that can be an additional $30,000 towards the cost of the software. So we really highly encourage you to take a look if you have a facility that's big enough to qualify for the MBCx program. It's a great option, and it will certainly enhance the overall retrocommissioning for your facility, as April is showing with all the different all the different stuff that analytics can really provide. That is just, it's more than an engineer looking at your facility is gonna find. Next slide. So with the RCX process, it goes through 4 different phases. Initially, we'll get an application from the customer. We'll review that application, make sure that the facility looks like it'll be a good fit. At that point, we'll contract with a QSP to come out and do some investigation with your facility. That typically will involve pulling a lot of trended data off, looking at your EMS, pulling some screenshots, as well as doing kind of an interview with your facility staff. So keep in mind that one of the things that this project and program will entail is some time commitment from your facility staff to make sure we get the trends that we need, that they can answer questions. In the end, we want to come up with measures that are acceptable for your facility. So we don't want to, you can save a lot of energy by shutting off the air conditioning to a space, but if that's going to cause more headaches and make your occupants upset with the whole thing, that's exactly what we're trying to avoid. We're trying to make it as simple and easy for you as a facility manager, but to also save you guys some money in the end. After the QSP completes their investigation, you'll get a detailed report that lists out exactly what you need to do to achieve the different savings from the project. And at that point, then it'll be on your plate to go forward with doing the implementation. So you can take that information that was in the investigation report to your contractor, your controls programmer. They can go through and make sure that they understand it. If they have any questions, QSP is available to go through and answer those and make sure that everyone's on the same page. Once implementation is finished, the QSP will come back, pull that data again, make sure everything looks right. And at that point, you'll get a final report really detailing, all right, this is exactly what you're saving based on what you were able to implement. Now, one other program within the retrocommissioning scope that we haven't touched on is our building tune-up program. So this is a great program for a facility that may not necessarily be a great candidate for a traditional retrocommissioning program. So as long as you have at least 15,000 square feet, you can be qualified for this program. What we'll do is we'll take a look at your bills and pull an Energy Star score for you. It needs to be at least 70 or less to qualify for the program. But based on that score, then we will hire a building tune-up QSP, which is more of an HVAC contractor to come out to your site and take a look at mostly your outdoor air make sure you're bringing in enough, see if there's any, economizers that might be broken, as well as looking at your scheduling and set points, make sure that those are appropriate for your facility. So even if you have a larger facility, if all you have is package units, it might make sense just to go down this path. It's a much quicker process than a traditional retrocommissioning, but at the same time, it will save you some energy without necessarily needing to, take all that time that a regular retrocommissioning might require. The customer commitment is even less on this. We're only talking about $500 for most facilities. If it's over 50,000 square feet, then it goes up by $500 per 50,000 square feet. Now, on the SRP website, we do list out all the different QSPs, including ETC Group, who just presented. They certainly have done quite a few projects within the program, but we do have other providers. And if you have any questions about, hey, who might be the best provider for our facility, we're always happy to help. Different QSPs are going to be experts at different facility types, so we can help you match up the right QSP for your project. Now I'm going to briefly touch on some of the other programs that SRP offers. We have our standard and custom programs. These are the programs that the vast majority of customers participate in. They have rebates for stuff like lighting and HVAC, as well as some refrigeration, compressed air, and other process kind of equipment. So if you have any upcoming projects, please let us know, and we can take a look and see if it might fall into one of these programs that we offer. Do keep in mind some of the overall customer cap issues. SRP runs on a fiscal year. That's May 1st through April 30th. And for that fiscal year, every year, a customer is limited to $300,000 per year. And that's across all sites that fall within that customer. So if you're like a school district and you have a bunch of different sites, we still would cap it based on $300,000 across all of those sites. But one thing to keep in mind is any of these payments that we're making to the QSP to pay for the studies and stuff, that does count against your rebate cap. So some of these retrocommissioning projects have actually run up against that cap just because they've found so much savings. So, I mean, when we're talking, in some of these projects that the QSPs identified over 3 million kilowatt hours in savings. Now, that's certainly not typical, but for some of these larger facilities, I mean, there can easily be 1 million kilowatt hours in savings, which, that's a good chunk of your energy bill when you're looking at saving maybe 10 to 12%. But I would say on average for these retrocommissioning projects, you're looking at about a 7% savings. So it's definitely can be more than just pocket change in the end. One thing I want to note is we are, continuing to monitor COVID-19, taking steps to reduce exposure. And so we do not do in-person meetings ourselves unless SRP offers to approve them. If it's if it's something that we really need to go on site for. But we are still available by phone and email if you have any questions on the programs, and we certainly want to work with you as best we can to find where your project might fit. Now, finally, for the drawing. So I want to congratulate Russ Fowler and Marissa De Lucia on winning the Nest thermostats, and we'll be in contact with you to get those over to you. Finally, here's my contact information. If you have any questions, please reach out to me on retrocommissioning or any of the other programs. And also feel free to reach out to your account manager, as they're always a good resource for any program questions. Now with that, I'm gonna look through some of these questions that we've had come in. For you, April and Chris, how accurate are the faults that that come out, and do you get a lot of false positives?
I can take that one. That is a really, really great question. And I think the answer is going to be, it depends on which software you use and how well that software is implemented. So most of the softwares will have some ability to do some kind of tuning. So maybe there's some constants in those rules and those algorithms we talked about that can be adjusted. So maybe a leaking valve isn't flagged until there's like a 5-degree difference, or maybe you want it to be a 10-degree difference and only catch the really bad ones at first. So they usually have some kind of flexibility where they can be adjusted to reduce noise or nuisance sparks, or maybe sparks that aren't, or let's see, I call them sparks, faults that aren't right. So there's potential for that, but with a little bit of effort and some attention, they can usually get tuned in to be very, very accurate and very useful.
All right. Can you go through a little bit about how you integrate the MBCx software with the existing controls? Like what that process looks like?
Yeah, Jackson, do you want to take that, or do you want me to?
I'll just go for it.
Okay. Yeah, so most of the softwares will have some kind of connectors, or I mean, essentially, right, they have to be able to communicate to the different protocols of the different systems. So a really important thing when you're evaluating using fault detection and diagnostic software is to be sure that it has the capability to talk to the systems that you have. So if you have a legacy building automation system, you'll want to be sure that there's some kind of ability to talk to, that systems can talk to each other. But how it gets connected is a little bit more complicated, so I won't go into great detail, but essentially we use a lot of like machine learning tools that help make some really good guesses. The computer makes a bunch of guesses about what does it mean when the point is called, you know, DMP or something, like all these abbreviations that controls contractors might be using. We try to use machines to like sort through and make their best guesses. So the processes can be anywhere from manual connection one at a time to really sophisticated tools to make the integration more expedited. So it will depend on what software, what people you use as your service, and again, making sure that those systems can talk to each other.
Awesome, thank you. In terms of like what facilities do retrocommissioning, just from our program, we've had a lot of healthcare, we've had a lot of higher ed, as well as offices, manufacturing, high schools, even some city facilities like libraries. So, you know, there's a lot of different options out there for facilities that can qualify. So that's why we kind of just have it based on square footage and usage, as opposed to trying to, you know, limit it to only one facility kind of category. Another question for ETC, you know, oftentimes with these kind of programs or projects, facility staff can be very reluctant because they're worried, like, how is this, you know, this looks like it could be a lot of work for me. How is this really going to help me reduce my workload, as opposed to just having a bunch of additional things that I need to fix?
I'll take that one. And April kind of implied a little bit earlier about preventative maintenance versus reactive maintenance. So, you know, going out to fix your failed valves and your failed dampers can save them the time chasing down hot and cold calls into the future. And I mean, that's a huge one. April showed the example of the chiller that was low on refrigerant and equipment wear and tear. You'd much rather have your chiller service technician come in and charge your chiller, prevent surge, and save the life on that equipment than have an unexpected failure. So those are a couple of things where a little bit of time up front can save you time in the long run.
Thank you. And then one other question with the MBCx software, does this only work on facilities with like a chiller plant, or you know, for example, what if I have an office buildings that's using water source heat pumps?
I'll take that one too. So the answer is yes, it's open to facilities with water source heat pumps. As Darren mentioned, there are some minimum requirements about the size of the facility and the energy spend of the facility to be included in the SRP program. Even if you don't have those amounts, you can proceed with retrocommissioning and monitoring-based commissioning outside of the program. If you don't qualify, definitely have you miss out on some assistance from SRP there. But the key is that, you know, a chiller plant is a nice boost. It usually means you're a higher power user. If you have a building automation system, that means it's a lot easier to connect up a monitoring-based commissioning platform, even if you have heat pumps or rooftop units, something that you can see them digitally in a BAS. But even if you don't have a digital BAS, there are ways that you could deploy remote monitoring. It may require some sensor installations and even some cell modems that send the data up to a cloud. So even if you don't have a BAS, there are ways that you can qualify. It just increases the installation effort and cost a little bit.
All right, well, I want to thank Chris and April once again, and thank you all for attending, and that will conclude our webinar.
Thanks, everybody. Thanks, Darren.
Thanks, everyone. Bye.